So, we continue our journey in the area of digital textile printing, and what we have learned till now is some of the printing technologies use piezoelectric crystals. So, we know what type of materials do give piezoelectric effect and what the effect is, and many drop on demand inkjet printing technologies use piezo excitation. Drop on demand technology also has thermal excitation, which means there is a bubble which has to be, a bubble is created by heating, and the heaters could be anywhere on the top, on the bottom, on the side. Like in the piezo also, it could be on the top or on the side, may share the walls of the chamber where the ink is there, and other type of excitations could also be there, which are ultrasonic and so on and so forth. So, one was continuous jet, the other is drop on demand. These are two basic principles. And also we learned that because of the complexities associated with the continuous inkjet, charging, deflection, ink recirculation, pressurization, etc., such print heads could be costly. The nozzles are actively replenished by positive pressures, and the operating frequency of these, that means the continuous inkjet print heads, are generally about an order higher than those used in the drop on demand systems. We also appreciate that the fabrication of thermal jets, that is thermal inkjet, is relatively easy and less complex. In the thermal inkjet systems, you have trapped bubbles which are air dissolved in the ink. This can also nucleate from the surfaces, can be trapped in the corners, and when the pressure is created by heating and generation of steam, that pressure partially can be absorbed by such trapped bubbles and can modify the pressure pulse, which would mean that you may have designed to have a certain amount of drop volume, where the volume may be different than what you had planned, which may not happen when you are looking at piezo based system, because that is based on displacement. So, thermal inkjet, although simple, may not be able to be used for pigment printing inks, which these days include the binder within the ink formulation, which obviously gets polymerized when you heat later, but it can happen during this process of generating pulses. So, today we will talk about machines, that mean print heads and general assembly of machines, and see what kind of processes generally are available and what we are supposed to be doing. So, the most important part of the machine should be considered as a print head. The whole system is very complex, and in a very short space, short size, short volume, a lot of things have to be included, and you expect right kind of size of drop to be produced at a right frequency, at a right time. So, all that makes this whole process complex, and in some way is not the domain of a textile chemical processing person. However, we can comment on some of the things. So, the quality of the image that is going to be finally printed on a textile would depend on the volume of the drop generated. So, if you can generate a very small drop, you will get a dot which may be very small dot. So, ultimately what we are saying is there are many dots which are going to be printed in different colors to give different shades, different tones. So, large is the drop volume, large will be the printed dot, and smaller is the drop volume, smaller will be the printed dot. It can also determine the quality of the prints as well. In early days, we produced large volume like 100 picoliters. Nowadays, it is possible to generate very small volumes of drops, which could be as less as 1.5 to 2 picoliters. That means we can become finer and finer. That control is available, and so quality of the image can be improved. But that would also make that you will have to not only have a small drop size, then the total number of drops or the points or dots to be printed will be also large. So, number of nozzles that you may have, they will also be large, and so all of them have to be accommodated. So, we express our resolution in dots per inch. Now, this inch has stayed with the printing industry. So, if you have let us say 600 dpi, that is a linear direction, then what it means is that between two dots in the same line, you may have a gap of, or let us say the center to center gap may be somewhere around 42 micrometers. Center to center I am saying is because the drop size may be large, then the gap between this circumference will be less, but this is how you can think of. Resolution sometimes also expressed as the two directions expressed, like say for example 2400 into 1200 dpi. What it means is that for a textile printing system, in the direction of the motion of the carriage, this is the fabric moving in this direction, the carriage is moving perpendicular to that. So, in the direction of the carriage, you may be having 24 dpi, and in the direction perpendicular to the carriage motion, which is the direction when the fabric motion is there, this could be 1200. This is what it means, and so this is how people define the monitors also in terms of pixels. So, here we have, instead of pixels, we have dots, which, as we said, smaller dots would probably be able to give sharper pictures. What happens if the dot size is larger than the resolution? Larger than, you have a matrix in which you are putting dots. If the diameter of the dot is larger than the matrix that you have generated, then there is a problem in the sense that the colors may overlap at those boundaries, and then you may get an effect which may be different effect than what you had planned for. So, one has to optimize in that sense that you just cannot. Therefore, the drop volume is going to be controlled. If you control resolutions very large, therefore, the drop size cannot be the same as for a 600 by 600 or 600 by 400 dpi resolution. Drop size may be larger than a 2400 by 1200 dpi drop size, and so the volumes will have to be controlled in that. What happens if the drop size is very small compared to the resolution? So, what happens if the drop size is very small compared, it is there, but very small. So, there is a matrix and in which let us say in a center very small dots are there. So, what you will see is a different thing. For example, the resolution is same here in both directions, but the drop size is different. So, what will be the effect? It will be as if you are producing a lighter shade, because the background is also going to be visible. So, more background is going to be visible, therefore, resolution could be same, drop size can affect the overall appearance of the design and the effect. So, you have variables, therefore, a print head today is able to print large drops as well as small drops. So, it may be a strategy which is a software based strategy. What do we do when we generate shades? So, it is quite possible that you may say, well, the resolution remains same, in that particular area you may have smaller drops, same color, that is possible. Other way of creating a different grayscale is that you have a lighter color actually, that the concentration of the dye in the ink is less. That also is possible. It is still called the magenta, but it may be lower concentration magenta. So, it can also do. So, your strategy could be either you change the drop size and then worry about the and get the appearance because the ground, or you actually use a ink which has a concentration which is less. Therefore, when we thought of earlier there are 4 colors can produce everything, that is true, but for technical reasons, for reasons of speed, for reasons of complexity, people may use more than 4 colors. I am not just talking about the white, they may use another color or a lighter version of the color to change. So, there may be actually 8 color printing systems also, which is different than the 8 color conventional printing machine, where there the colors are already prepared for the shade which is there. Here the shades can keep on changing based on the understanding and the resolution of the software. So, but you may still have more than 4 colors. So, complexity in one of the typical examples is like this particular print head, which is made by SECO, called 2020, for example, has something like 255 active nozzles. So nozzles may be more. Let us say you have a shared wall. So, you may ensure that only one of the side one starts, the other one is not firing. So, all of them fire, then there could be something different. So, you may have active nozzles at a given point of time. You may have drop size delivery of 35 picoliters. The drops per second may be up to 20,000. So, you see this is a complex thing. What is the second time? And this you are actually hoping all of these things are going to happen. There can be identical print head carriages. So, instead of one carriage you can have 2 carriages, and each carriage can have 8 print heads, one for each color. So, if you are looking at 8 color system, so you have so many print heads available, and then this carriage moves. So, that means you are covering more area when you move. So, if somebody says increase the speed of printing, because this has to go like this and then come back. So, in one go you are covering a large area. Obviously, it has been calibrated correctly, so that the area of the picture and the area on the fabric is matched. Obviously, the picture size is on a small monitor, but it has been calibrated so that finally the resolutions are matched, separated ink information is matched, and so firing takes place as it moves. The carriage speeds could be very high, in inches they could be moving 20, 40, 60. So, as you grow into the technology, the printing speeds will have to be increased, because that means production. It is like a linear system moving one way, or sometimes when you move in one direction you print, then you come back in the other direction you print. So, you can keep increasing your speed. So, the time utilized in this whole business of motion of carriage. The assembly could be like a sandwich, but the total dimension may not be very high at the point where it is being printed, because the main storage may be somewhere else. It is being fed and then it is being jetted as is required. So, it could be hundreds of piezoelectric systems sitting on top of this, and which are called the drivers, like you have an LED lamp, there is a driver. So, you create completely the circuitry and voltage controls, and then you have ensuring that there are porous systems, which are porous in the sense that if you really look at from a naked eye, you may not be able to see that there are so many holes there, and then ink flows from one layer to the other, and finally, which is a nozzle plate at the bottom from which the ink is going to be jetted out. So, very small assembly, but has got everything, the circuitry which controls the firing and various sandwich systems. For example, there is a project which was called the Dream project, which means that there is a company which makes the machine, there is a company which makes the print head, and there is a company which makes inks. So, what was understood was that you must collaborate, and if you do not collaborate, then you design a print head which may get damaged because of the conditions of the ink. Ink may be aqueous, it may have some chemicals which may not be suitable to the adhesives which have been used, for example, to create a print head. So, in this, Regini, for example, is the company and uses another typical print head, let us say Aprion. Now, this print head dimension, as for the dimensions are concerned, the print head may be large, thickness is very small, but up to 600 dpi it can print. Number of nozzles could be 512. Operating frequency is 300 kilohertz, pretty high. Mode is binary, that means either it is there or not there, and it is a rooftop piezo drop on demand type of a system. So, the possibility are here. So, high frequency, number of nozzles are very high, can produce 600 dpi and has drop on demand rooftop piezo. So, somebody says that how will the speeds, let us say square meters being printed per hour. So, it is easy to understand that if your resolution is high, the speeds will become slow, but if you want high quality, again you may reduce the speed. So, drop size control. So, how much area you can cover would depend on how many drops are going to be put. So, even for a high quality thing, the speeds can reduce. If you go for high DPI, the speeds can reduce. This is a typical example, does not have to be followed as it is. So, both the things, when you increase the DPI, the speed goes down like this, speed is going down, or if you increase the quality, then the speed goes down or the same DPI. So, productivity of a print head, let us say there is a print head productivity pH, is the volume of the drop, volume the frequency, and the number of nozzles. So, if you produce more volume, so maybe you can cover more area. If you have high frequency putting the same amount of volume at a high frequency, you can cover more area, or if in the print head you have more nozzles, they can cover more area. So, that is how a print head's productivity would be defined. Sometimes you can define it by productivity per nozzle, in which case you have only V and F. It is again repetition of the previous thing, that the drop on demand, the frequency, as we said, whatever the frequency, 10 kilohertz for example could be, or more as we have seen before. But for the same kind of quality, the frequencies to be used for the continuous inkjet would be 10 times more. Generally, if you have 100% coverage, then the ink required approximately is 15 to 20 milliliters. So, you are not really looking at a very large volumes, but you are spreading this very effectively. In case of conventional, the amount of volume of the paste that we use is very, very large, because there are so many things which you do not want, but it will wash later on. In this case, everything that you use is more or less being used. Inks may be costlier, but you do not use too much of ink. You use just the right kind of ink. There is no wastage theoretically. So, we look at the printing machine as a whole. A typical printing machine would have a feeder unit, a printing unit, drying and folding. This is the digital printing part, but you may have to do the pre-treatment to the fabric, which may be done on a separate machine before you feed. So, the fabric, let us say a very lightweight fabric, a knitted fabric, a piled fabric, or something which has got a lot of protruding hair, may have to be first done, given a pre-treatment, so that the surface becomes smooth, dimensions are controlled. That it should not happen, you put a little bit of tension and the skewing takes place and you are not able to do this. There can be difficulties in printing and your designs can go haywire. So, the machines may be for that different, but the printing machine would have a feeder unit, which would mean that controlling tensions, controlling the conveying the fabric into the machine correctly. And then after this you have actual printing taking place, where there are jets, the print heads which are working, and then of course you dry before you do anything else, can fold or do whatever. So, it could be a pre-treatment, could be padding and coating. If you think only one surface is important, you can take care, you can have a coating system, some type of a polymeric things which gives little viscosity, so that it gets taken care of and surface becomes smooth and the ink does not bleed, because there is viscosity is low, capillary reactions etc. can take the ink from one area to another area, which you would not like. So, it would like that too. This pre-treatment can improve the feed performance, like you are feeding the roll of a fabric to the printing unit, actual printing machine. So, let us say hard twisted fabrics. What are the hard twisted fabrics? Wherein the fabric, the twist is high. What type of examples of those fabrics? Crepe. So, crepe, georgettes etc. So, you can have hard twisted fabric, which obviously can extend their dimensions based on tension. So, you may like to do some kind of a treatment to that. Stretch fabrics, these days you may get material to be printed which has got inbuilt stretch, or knitted fabric for that matter. and you want to avoid skewing and also sometimes control slippage. Very, very shiny, slippery surfaces can also have difficulty. So, you may have to make sure the dimensions remain controlled. So, the pretreatment will be there. Other than that, of course, for different inks you may have other chemicals which also may be there as a pretreatment part. So, you do a bit of a stretching here, so that if there are wrinkles which are also removed and then you have treated them. So, it becomes a stable structure. And this machinery may also be having a drying system. So, you have a pretreatment machinery which not only does padding or coating or stretching, but also dries. So, you cannot take a wet fabric and start printing. So, unlike what we were looking at the transfer printing system, which appeared to be very, very simple, take a paper, take polyester, heat it up and finished. Here some other things would be required which increase the scope of this printing system, that you can use different colors, different types of chemistry of colors for different fabrics. So, coming to the printing part of it, if somebody asks this question, is this inkjet printing continuous printing or intermittent printing system? If we understand this, you have seen rotary screen printing, roller screen printing, they are called continuous. So, this type of a system, is it continuous or intermittent? It actually not continuous in that strict sense, intermittent. That is, when actual printing has to take place, when the carriage is moving from one head to the other, the fabric must remain stationary. So, the design is there. If it fabric is continuously moving, the print head moves perpendicular. So, what you will see is that the fabric is moving in this direction. You intended the design be here, but the design may actually be printed like this, and coming back it may be printed like this. So, you may not be able to do anything which is justice. Although, if you see high speed printing systems, it may appear that it is going fast, but if you look at carefully, first one row, once it is complete, then it will move. And if half design is on one side and the other half is being printed to the other side, then it will move after the whole that linear area which is to be printed from one end of the one selvage to the other selvage. First it gets printed completely, then it moves. The basic print unit may be 3 meter by 6 meter, 3 meter wide, 6 meter long, which would have everything: inking stations, all the print heads, the carriage, the motion, everything else would be there. Typical machine may have industrial versions for the textile printing, may have roll to roll configuration. You start from a roll, finish on a roll, but that is not it. You may have machines which are printing piece goods only, like a t-shirt or a small piece or something. So, this will be conveyed and then you keep printing. But a typical fabric printing machine would have a roll on one side and the roll on the other side possible. So, speeds would obviously vary on the kind of print head that you use, but this is slightly different than the normal printing that we do, that here at least this machine should be kept in relatively more controlled conditions. The pre-treatment or the post-treatment is not going to be in this area, because there you may be having drying of a different kind, curing of a different kind, steaming you may require, washing you may require. That does not require conditions of control conditions of temperatures of 25 degrees or humidity control of 50-60%. So, this zone will be different. So, even if you want to have a continuous system, which most probably will not have, pre-treatment done, make a roll, bring the roll here in an environment which is closed, print completely, take it out and do whatever post treatment you have to do. So, within this so called printing zone, you may have done a good job there, but it still would have its own spreading mechanisms, entry to the printing machine. It would have tension control system, so that fabric actually is being fed correctly. Adjustment of speed may have to be done based on the print head systems and conveyor. This is definitely controlled. So, what do you do? As we said, intermittent. So, you have a stepper motor system. So, motors will move in steps, so that the fabric to be printed also moves in steps. So, this ensures that the feeding of the fabric and the transport is controlled. So, this entry part of a machine is an important component which is precise. So, here everything is precise. You are looking at stepper motor accuracy of few microns, you are not looking at millimeters. So, that would mean that everything is controlled now, and therefore, the cost of the machine becomes high. It is not like a normal gear or belt based motion which are used generally. Then we are done in the other printing process also. So, there is a blanket, there could be a blanket which is endless blanket, and you will do some binding of this after you have ensured that everything is coming correctly, then you bind. So, all of them move in the same way, the blanket speed, the fabric feeding speed, everything is same, and the blanket after printing obviously is the endless blanket comes back, it has to be cleaned. So, that again you apply some gum, it again is pasted. So, as the blanket moves, keeps on printing, then fabric is removed, the blanket comes back. So, think of that when you are actually doing cleaning, that means there is a water consumption. So, it does not look like a dry printing process, unlike what you see in inkjet paper printing, everything looks dry, because paper itself is dimensionally quite stable, unlike the textile. So, all this is there. So, you would be having within the system some water inlet outlet cleaning process covered, so that nothing else gets wet. So, controls have to be there. So, digital inkjet printing for fabric is complex from technology, but also from the desired requirement that we have. So, in the print point you have a carriage which got, as we said, many number of heads may be there. Carriage may have 1 or 2 rows, adjustable speeds. The gap between the nozzle blanket and the surface, nozzle and the blanket surface can be adjusted up to 40 millimeters, That means thicker fabrics can also go. If there are thinner fabrics, you will obviously reduce the gap, so that the spread is not there. If the gap is too much, then ink, it is being fired, for example, by continuous inkjet systems going at an angle, it may land somewhere else. But if fabric is thick, then obviously you take the nozzle plate up, but still remember, this is non-contact printing. So, machines can print flat fabrics, velvets, nonwovens and so on and so forth. The ink obviously has to be replenished as the ink has been done. So, if it is a continuous system, So, you can have ink feeding as it goes to one side to the other side. Ink can be fed from both sides to the carriage system. So, interesting. So, you can have 6 color systems, which is CYMK plus orange and blue, or you can have CYMK, C light, M light, or you may also have black, light black, that means towards gray, right. So, you can have 6, we can say 8 also. You can have 2 grays, 2 more colors or 1 white, and this is how you can keep ink. So, 8 color being used now is considered as a common thing.
More color is for more quality or more production?
More production also, more production. You can actually, there is a large area which requires light things. So, instead of using to control the drop size, you keep the drop size large and use the other one. But it is not infinite any color that can be. There all colors have been correctly calibrated that the image is going to be there. Like cyan light and magenta light will give you the right kind of pickup. But because that area requires less, so you can have a larger volume of the drop, but a lighter size will give you the same effect as small drops, a large number of small drops and then area. So, that is the production could also increase. So, then you take this out of the conveyor and then dry before you take it for post printing operations. So, this has to be done. You can wind on rolls or fold. Generally, hot air is used to dry, just to dry, because most of the inks may be aqueous based systems. If it is a solvent based, then it dries quickly, but if your fabrics are generally hydrophilic, you may want aqueous system. Some penetration in the depth also may be a good idea. So, a typical fabric machine, printing machine may be looking similar to what we have seen somewhere. So, you have a fabric roll, then you have an endless belt, where after some controls, stretching and pushing, you apply, fix it here, it moves in the print head, gets printed, and then you take it on top, dry. So, this is dryer, and then you can fold or roll. Now, this part is definitely intermittent, which is the print part, but here you can adjust the speed in a manner that it would appear that this is a continuous process. You have stop and you have an excess fabric being there. So, you adjust the speed in a way it would appear as if this one is regular, everything is moving from here regular. So, that adjustment can be done because you know how much of the fabric per unit time has been printed. So, in this type of a typical machine, you have carriages which are moving, right. These days, so this carriage, of course, the image which contains is something called a raster image, you know, this matrix and the dots or pixels in the image, they call the raster. The other image formation format is called the vector image. The vector image is basically a mathematically derived system. What it means is that if you want a larger area or expand the equation, the mathematics will make sure that everything looks good. In a raster, if you have a small resolution and you try to enlarge, you will see pixelated images. But if you fix the resolution based on what you want, the life could be good. So, some of the things in the formats which are JPEG, GIF, PNG are some of the formats which have the raster. So most of the machines that you use obviously have to understand the information which is coming from somewhere else. The information may be there is some design station who is making image, there is another station who is scanning or taking a photograph. That format must match the format which the machine understands. If you try to get any other things, so it may not work. So these days people use Photoshop, which creates these kinds of formats also. Hexachrome systems, which are 6 color based Pantone, they take anything designed on graphic software like net graphics and so on and so forth, also will be creating design, and after that images which will have format like this, which is raster format, and which will then be understood by the machine hardware software so that it goes correctly. So input for the printing, as I said, can come either as a combined color information, which means information is coming as an RGB or the LAB format, or it can bring information already separated in grayscale. So yellow and its complete grayscale based system that you have separated out, light yellow, green yellow, light yellow, dark yellow, etc. So you separation comes, so information comes in grayscale, off for yellows, for magenta, for black, and that is fed. So this all machines normally would be able to understand any of these things, just to make sure there is universalized, Otherwise people say use only that software, then becomes more problem. So some of these common formats and common system information would be fed into the information by any mode, by wireless or wired mode. It will come and it will understand. These days people are now trying to promote machines which are called single pass machines. So what it actually means typically is that there is no carriage which is moving. At the moment, what is the print head? I have got 8 colors, all the carriage contain the 8 colors, and all of them move together wherever it is required, they print its color and then keep moving. In this, they are saying, why move the carriage at all? Let there be, like you have a rotary screen printing, 8 color system, 1 color per screen. So why can't we have 8 heads covering the whole thing, and wherever yellow is required, just giving yellow there, and then next station puts the cyan, next station puts the black, and so on and so forth. So don't move. Why? Because you are now looking at possibility of speeds as high as 100 meters, which is very high, very high. Normally in the carriage system, this kind of speeds will not be. So now you are looking at this. So print heads are fixed in stationary rows. The conveyor belt is transporting the fabric, which was anyway doing in the other case also, or either to print fabric or sublimation paper for the transfer printing purpose. So same machines can be used for transfer printing, the same machines can be used for printing fabric directly, but obviously inks are going to be different. And so less moving parts in the digital printing. So whatever digital inkjet printing, if you see at your home also, there the carriage is moving. But carriage moves for a A4 size paper, for a A3 size paper, is different than a 2 meter, 2.2 meter wide fabric where a large amount of motion has to take place. And so this itself takes time, even if you do very fast. If you say, well, now we do not have any situation, we are going to only keep the heads fixed. Good idea. So people are trying to promote single pass machine. So, one pass one color, the other pass other color. It may look like this. So, different colors at different points. Fabric moves from one direction, goes to the other direction, conveyor belt does whatever it does, fixed print heads, 6 color, 8 color, whatever, 4 color, you got what you want. So, this could be the type of machines which you will see more often for textile printing. And some examples are there. For example, a company at the bottom, say the Stock was one of the companies which was making printing machines anyway. So, they use a printer which is called a Pike, they use a print head which is made by Fuji films, the ink that they use is reactive. Konica, Minolta, no, these kinds of the photography people, they are in textile business, all right. So, you have a printer made by some machine company or name is called Messenger, Konica, Minolta, print head, and drop size can vary from 6 to 30 picoliters, dispersed reactive. Another company as the top talk about is different company making print head, different company making a printer, different company marketing, and says well drop size is very large, acid, disperse, pigment, reactive, sublimation, anything can be printed. Now, so single pass printing machines may become more important. Post treatment, as we said, would have steaming, curing, washing, drying, calendaring, and then based on what type of a color that you have. So, steaming etc. for reactives, acids, curing for pigments, washing of course if required, and drying, calendaring. These are the simple treatments that you anyway would like to do. So, we can stop here, and next time we will talk about inks.